dive into this. Y'all know I care about you so much and your success that we are going to walk slowly through this one here. This class is going to have a perfect end of year exam rate. I just know it. Um, yeah, if you believed any of that stuff, I'm just kidding. All right, this is going to be on YouTube. This is great. I believe in you. The first thing on this guy here is to always look for what is the equivalency kind of like statement being talked about. And it kind of gives me that the area of those two pieces resemble those expressions. Now, kid in another class mentioned like, wow, those shapes are so ugly, right? And they were totally right. It is ugly, but it has nothing to do with the shape. We're not taking rectangle equal to rectangle. What we are doing is just looking for this simple statement. The total area of both is 4 meters. Meaning, the first thing I would do is build it out. X squared minus 4 all over x squared plus x minus 2 added to 6x squared plus 23x minus 4 all over 6x squared minus 7x plus 1 is equal to 4. It's an ugly, hideous statement, but it's our statement, and we're going to love it regardless of what it looks like.
Yeah, I'm going to tell something after.
Thanks, Cameron. I was basically gonna add in the joke of like, much like most of your parents. But that would have been over the line.
I could say
that would have been over the line. Okay, so moving on. Step 1 is write out the statement. Step 2 is just going to be factor every piece. So, JC, fantastic approach when you said like, I'm legit just gonna look at one piece at a time. So I'm going to start by factoring this guy. I'm going to recognize that on my memory aid that this guy is a difference of squares, and then just write x plus 2, x minus 2. I just am. Okay? The next piece, we're going to factor x squared plus x minus 2. Right? So we do our Munchkin numbers. What plus what is equal to 1? What times what is equal to negative 2? 2 and minus 1. 2 and minus 1. Because this is a pumpkin spice latte version of our factoring.
They don't understand that though.
What? That it's basic? No, they I think most people in the world know pumpkin spice latte is all about basic. Ladies. So x minus 1, x plus 2 is my answer because I don't have to go through the long version of this. Now, those two are done. I can rewrite it if I want, but I'm going to do the other pieces as well. 6x squared plus 23x minus 4 is going to get me to try and find what adds together to make positive 23, but multiplies together to get negative 24. If you have numbers that are next to each other, do not overthink it. It's going to be some combination of 1 and 24, 1 and 24. If ever it's like 24 and 23, or if it was 24 and 25, the numbers you're going to choose.
Basically, what you're saying is if it's this falls immediately by
the next number, yeah.
Regardless of whether the top or regardless of whether this or the next step is negative.
Yep.
It's always going to be
one and.
It's always going to be one and next step.
The number, yeah. So because now I'm going to look to it and say, how do I make positive 23? The 1 would become negative. This guy is not a pumpkin spice latte, and I have to break this one in half and go 6x squared minus x plus 24x minus 4, and then do my regular factoring with that guy. So common factor out x, 6x minus 1. Common factor out 4, 6x minus 1. This guy would turn into x plus 4, 6x minus 1. So this is why factoring has to become second nature, because if I screw up any of these stages, then my next step becomes an unmitigated disaster. So 6x squared minus 7x plus 1. I'm going to find what adds together to get -7 and multiplies together to get 6. Hey, look at that. I have two neighbors again, so it has to be 1 and 6. It has to be 1 and 6. And in this case, because I'm making -7, both of them have to be negative. -1 times -6 would give me a +6. And again, because a is greater than 1, I am going to break this into 2. -x minus 6x plus 1. And then common factor out the x. Common factor out -1 so that these guys match. And then I'm left with x minus 1, 6x minus 1. So I'll zoom out. Factored every piece. Step 3 is to rewrite everything pretty. Right?
Do things cancel out?
Yeah. Question?
Yeah. After we rewrite it,
Some things cancel each other out.
do you foil it?
No. So that's a common mistake. That's a great question though. It happens all the time. Like people like factor it out and then foil it back. They just kind of go frontwards and backwards, or it's kind of cyclical.
Yeah.
But you see it and you're like, oh, I should foil it. But it's like, no, the purpose of me doing this, and I'll just show you as I write it out here, add 6x minus 1, and then what else was on top with that one? This is what you'll screw up too. X plus 4, perfect. And then 6x minus 1. Oh, it doesn't matter. Same thing. So then x minus 1 is all equal to 4. So I've now rewritten it in a prettier, although still a little ugly, way. So now I'm going to cancel out. Now I'm going to cancel out what I can. One of the common mistakes I see as well is people will cancel out those two guys. Why can't I cancel out the denominators there? That's weird. They canceled us over those who aren't looking. There's people that canceled out this guy and that guy. That would give you, well, it would end up just becoming like 1, but that's just a common denominator. And in fact, if you look at it here, numerators can cancel denominators. Numerators can cancel denominators. But common denominators are what I'm looking for. So the simplified version of all of this, and if you get to this stage, my goodness, are you ever crushing this? Okay? That now I can rewrite it again as x minus 2 over x minus 1 plus x plus 4 over x minus 1 is all equal to 4. Now, because I can't pause this, and I wish I could, I'm going to finish this out. I'd like you to almost try it out on your own. But this part of the question, in my mind, ends up becoming the toughest. Not this step, because now that I have common denominators, it's just 2x plus 2 over x minus 1 is equal to 4. Let me freeze there for a second. Does everyone see how I got from this to that?
Yes.
Yeah, you added the top.
Denominators are common, and make sure that the denominator still stays there. He didn't disappear. He still exists, and now he is the bane of my existence. This was from a midterm I wrote 3-4 years ago, or had kids write 3-4 years ago. And I will say that a bunch got to here and then tripped over the finish line. And if I just gave you that problem independently, I know most of you would be able to solve it.
If we couldn't get past this step, what mark would all of this work be? Like, will we pass the question?
Oh, goodness, yes. Like, it'd be a floor of at least 7. Like, I could reason giving you a 6, but I'd probably give you a 7 if you got down to here. And then did stuff with that number and kind of flowed through it properly. This one's hard because as part of a C1, I just take into account that you got most of the problem correct for this concept. You know what I mean? So like I'm going through all 5 sections and saying, did they know what they were doing? Did they know what they were doing? Did they know what they were doing? This, if you got all the way through here, it would be like, I would say, yes, they've kind of demonstrated mastery of this topic. They just forgot like basic algebra at the end, which again, it's more of a judgment call. But what I often see with this guy here, oh, where'd he go? There we go. What I often see with this guy here that people make a mistake on is that denominator right there. How do I get rid of it? It's ugly. It's bothering me. So we're literally just going to move it upstairs. I'm taking it off the denominator because I multiplied that side by x minus 1, and I multiplied the other side by x minus 1 to leave me with something a heck of a lot prettier. Okay? What is different? What do you notice right now is different for this question versus all the ones we've done previously?
Everything can be factored.
All the other ones can be factored. Do we factor this one? No, in fact, if I just gave you this part as an algebra problem, you'd be able to solve for it, right? Bring this guy over, bring this guy over. 6 is equal to 2x, divide by 2, divide by 2. X is equal to 3. One answer, that was it. This question is a lot different and almost easier because there's only one answer. So I had a great question last class saying, like, how do I know when I can just solve it like a regular algebra problem versus when I have to go up here and take something like that 4x squared minus 8x minus 5 and then factor it to get those two pieces there? How do I know? Well, really and truly, if you want to kind of like think about it on a more fundamental level, let me just draw this for a second. Sometimes you're going to be given questions where it's like there's going to be two answers, right? That would be me asking you to find the points of intersection of a straight line going through a circle. We'll do that in grade 11 next year. How many answers, how many times does that line intersect that circle? 2. So this question is likely going to be, or not likely, it is going to be 8x minus 5. It's going to be a trinomial. That's why some of those questions work out that way, is because there's two potential answers. So that's why I have to factor it or quadratic equation it to get the two answers. What happens if I had a linear function running into a square root function? How many times did these two guys run into each other? Once.
So you're kind of confusing me. How'd you get 6? What'd you do?
Adding 4.
Okay.
Subtract 2x, subtract 2x. Yeah. Yeah, just let me explain this first. So if there's a question that when you bring it down to its simplest form, it's a trinomial, you have to factor it. But if there's a question where when you simplify everything, does anyone see an x squared at this stage?
No.
So it's not a trinomial, meaning I can literally just solve for a singular x. So sometimes if it's like this, you're going to get 2. You choose one to accept, one to reject. But if you work it down and all of a sudden you just see singular x's, phew, I don't have to go through the nonsense because there's not 2 to choose from, there's strictly 1. That's a hard thing to wrap your head around. I'm going to back off a bit here and let you think about this and let you copy that guy down. But in a nutshell, that's this question. There's only one other aspect to it, and that is what to do when I get the x is 3. But we'll do that in class here. I'll finish the video here.